very large-scale projects for clients like the U.S. Navy. They were not asking us to do this in BIM. We didn't even deliver the BIM to them. We basically delivered mainly paper and maybe some CAD files, but it all started back here. And the first project we started in BIM immediately opened our eyes and said, "Well, this is very different. This is not just another tool. It's going to change everything about what we do." Even before 1993, in the late 80s, we were into using 3D modeling and databases, and the hanger object that you see on the right is an intelligent object, basically a parametric object that we built in-house, that as you stretch it out, it recalculates components and helps you make rapid design decisions. The graphics, we've done quite a bit of presentation in glossy graphics, but really that's not our focus. We like the way things look and beautiful 3D models and everything, but you'll see as I go through my presentation what I mean by that. I'd like to jump to an animation really quick. And this might lag a little bit, but this is a pretty quick animation, but we'll get back to some of the main points later on this. So getting real with BIM. Here's to architecture. We dream about the past and we predict the future and build it. We're problem solvers. We like to tackle things and resolve things and connect the dots. Some people think we're crazy. We're legends. We teach and inspire, think outside the box, create poetry with gravity and light. We build and inspire. We design everything from chairs to iconic buildings to entire cities and move civilization forward. But there's a problem. Henry Ford once said, "If I'd asked my customers what they wanted, they would have said a faster horse." The building industry is pretty much stuck in the 19th century, using processes and tools from the past to document our ideas and decisions. This is even true with BIM. BIM is not being used to the full potential, and that's an opportunity. The 21st century train is rapidly leaving the station, and we want everybody to jump on board. The U.S. Coast Guard once said, "The data about our facilities is more valuable than the physical facility itself." In other words, the information of the facilities over the life cycle is more valuable than the building itself. The eye of BIM drives everything. We're in the information age. Information drives everything, and if we must become masters of information-driven design. Open standards and a lot of tools are needed to solve this. There's no single application or tool that's going to solve it, but everything should be made as simple as possible, but not simpler, as Einstein once said. The tools have existed for years to make decisions in real time on the internet. You ask it a question, you get a response in real time, zero training. The technology like this is what needs to drive what we do in the industry. So it can start with a simple form like this, saying here are spaces in a building. This list of spaces can drive geometries, simple geometries. The ONUMA system is a BIM server on the internet. It's in the cloud with many different interfaces, all the way from just tabular data to graphics to 2D to 3D to geographic information systems. BIM storms are workshops, charrettes, collaborations that have happened with thousands of participants from around the world. This is a 24-hour BIM storm that Penn State was involved with, 130 teams from around the world. It starts from the world level view. You drill down to a city level. In the city you see buildings. In those buildings there are floors with spaces and equipment and rooms. In the room there's equipment, data driven, that says here the lights are on in this room. So being able to connect geography to buildings is critical, and to be able to make decisions relating to everything about energy, about cost. So latitude and longitude connected to BIM is critical. BIM storms, we invite you to join BIM storms. We have ongoing BIM storms. If you go to bimstorm.com, you can find out more information. We just recently had one in Washington, D.C. Here's a client site in Google Earth. We've circled the area. The client says that we want 316,000 square foot building, mixed use, housing on top. Here's the Excel file for that building. Imported now into the ONUMA system, automatically generates the first version of a building on the site, now in Google Earth from the ONUMA system. Nobody's touched the design yet, other than stacking and blocking it in Excel, but we can start having discussions about, is this a good idea to place it on the site? what do we have on here? How do we rearrange this now back into the ONUMA system? It's basically like sketching with data. You move things around to get the initial configuration of a building based on that programming requirement from the client. Within minutes, you have another version of this design. So running through different scenarios that drive decision making and design. This is coming from the inside out. Then we take the same model and take it out to SketchUp. So the Excel file through the ONUMA system out to SketchUp now, automatically generated. Now out to Revit. Open it up in Revit and you don't have to type in rooms and names. Basically it's the same data that started in Excel now has created spaces from the ONUMA system into Revit, and you can continue on with Revit. Once we get into the life cycle after the building construction is complete, that's when the information of the building kicks into high gear. This is where the value really is. Managing buildings in real time. Buildings change over time. How do we manage that is critical. Buildings move and change. Cloud computing on the internet allows real-time collaboration with teams. It's really about connecting people. It's not the tools. It's about people connecting, making decisions, like owners being able to view their space in a building without knowing anything about CAD or BIM, or connect real-time sensors with webcams or equipment data into the BIM on the web in the cloud with temperature data streaming in from different servers, color coding of spaces, viewing a BIM in a simple format. Here's a single room on the 33rd floor. We don't need the rest of the building to start having discussions about what is that room about, why is it red, something's going bad in that room. Once the building is complete, you could see that relationship back to the entire building and the same temperature data of that room. That building is connected to the city. The city is obviously part of the larger global environment, and being able to connect the dots between a lot of complex data in a simple format allows decision making to happen and drives better design. This is our view of the world, and this is something that we're doing today. It's not science fiction. We've been doing this for years. It's not something that can be solved by any single organization or single person or single software. It's about connecting the dots, making that faster horse, looking at the whole life cycle, not walking away from the building at the end of construction. The buildings live for a long time. A lot of clients have a lot of existing facilities. That also drives a lot of need for decision making. So that's our quick overview of what we do. And let me jump back to the PowerPoint, and we'll get back to some live sessions after that. Okay, so as I mentioned, information is a valuable asset. Like the Coast Guard said, the information about the building is more valuable than the physical building itself. Unfortunately, most building information is kind of managed like this, in binders or in boxes or even in CDs that are not connected. If you think of the way that the airline reservation system that I showed earlier, if we had to print out an airline schedule to make a reservation, it would not work very well. Unfortunately, the building industry pretty much functions like this today. Static file-based data in a CAD file or even BIM files that are just stored on a server do not let you access information very easily. It's really critical to get to the data inside those models, whether they're 2D or 3D. Open standards, the National Institute of Building Science and Building Smart Alliance really supports the need for open standards. Open standards meaning that we can move information from one tool to the next in a non-proprietary format. That's absolutely critical to the success and the sustainability of our decisions that we put into our different tools. So if you look at the life cycle, there are different tools that are great along the way for different parts of the process. There's no single application that can solve all of this. And this is the new model. A lot of owners are demanding now that they want their data in an open standard format, and I encourage all of you to look at what's happening with Building Smart. It's an international organization. Building Smart Alliance is North America. It's a great place to network and find out about what's happening in the industry and the standards out there. We're much involved with this. The Building Smart Alliance also puts out a journal called the Journal of Building Information Modeling every quarter. This is an article and a cover that we created called Location, 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 BIM, 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 looking at geography connecting to BIM and how critical that is to decision making and portfolio management and building management. So back to the airline schedule. You don't have to be trained on how to use these web-based tools, but there's a lot of really complex data in the background. You don't go to a site like this and print out today's flight schedule and then expect to come back and be able to buy that seat. The reason this works is because it's real time. You don't have to import from one system and export it to another system and import it back in to be able to make a report or reserve an airline seat, or to find out what's related to that place that you're going to, which hotel is in that other location. So as we all know, with smartphones and the way the internet's going today, everything is starting to get connected, and massive amounts of data is being processed through your smartphones. That's where you want to take the building industry. Unfortunately, the building industry is not there yet. The airline industry, there's very few mid-air collisions. In the building industry, it's been proven that close to 50% of our flights are mid-air collisions. In other words, there's always problems with design and construction and cost and facility management. So we really need to streamline that process, and that's actually an opportunity for architects. If we can hone in on that and see how we can change the industry, it creates greater value for everybody. Even the US government is getting into cloud computing and looking at how to streamline the different, instead of having a lot of what are called stovepipes, different tools not talking to each other, opening up data and being able to share it in an open standard way through the cloud. A great book, maybe some of you have read this, Big BIM, Little BIM from Finance Jernigan, really explains a lot of these concepts in a simple format. I really highly recommend you taking a look at this book. So in our world, there are many tools. These are just some of the tools out there, and we don't use all of them, but we connect to a lot of these. In fact, all of these on the screen are connected through the ONUMA system using open standard exchanges such as COBE, Construction Operation Building Information Exchange. It's getting a lot of attention in the industry right now as far as how do we share data once the building is complete to take it into facility management. As an architect, I've been very frustrated over the years that obviously architects are great at connecting the dots, designing great buildings, designing cities, but we pretty much walk away from the result of our effort when the building is complete. Yet we've put a lot of information into that, so how do we make that information valuable for the life cycle? So the ONUMA system, we've been building this for many years. We've initially used it in-house for our projects, but then our clients started asking us to use it for their own projects, so we licensed this system out now. It's been used for many award-winning projects. It's on our own server, it's running on the Army Corps of Engineers server, it's run on the GSA server. We've used it on Homeland Security projects. It can start from many different angles. There's no linear path to any of this. You can start from an Excel file. So in our world, an Excel file is a BIM as long as it's structured data. You can import that into the ONUMA system from the desktop Excel file, and it creates a first version of a blocking and stacking model. That can have other data associated with it. So for example, air changes in a room, or the floor finish, or the lighting levels, or the noise level. And you can drill down to an individual room with furniture and equipment. We intentionally keep the geometry very simple at this point, but it has a lot of data that can inform the design. In the opposite direction, we also tie into geographic information systems, so everything has a latitude and a longitude and can connect out to other GIS tools such as Esri or Google Earth. Some of this looks foreign to a lot of, when I present this to a lot of architects, they kind of look at this and say, well, this is really not about design. And the reason we built this system is to give us more time to spend time on the fun stuff, the design, the crunching of data, the creating of the geometries of the building, making sure that you have all the programmatic requirements that the client asked you to put into the building is always a struggle. And it was very surprising to hear from clients like GSA that they give program requirements out to design teams in an Excel format basically, and the design they get back can be up to, they said, I thought they were giving us the wrong number, but they said 50% off sometimes. I thought they said 15, but it was actually 50. So that's an extreme example, obviously, but it's pretty common to have a lot of things missing because of the complexity of buildings. So if we can automate the complexity, we can spend more time on design. So the ONUMA system is used for early planning, and then as we go into design and construction, the engineering BIM applications such as Revit or ArchiCAD or the other BIM applications, we connect to them. So we run a parallel to the other applications. So in the early planning phases, by keeping the data in a simple format, allows more users to interact. Not everybody can be a BIM expert, and not everybody can use all the tools out there, but we need this data to connect from one tool to the next. So you can start with Excel, put it into the ONUMA system, or start directly in the ONUMA system, pass that on to the other desktop applications like Revit or ArchiCAD, but we still keep it up in the web so we can start doing comparisons of what's going on with the design, what was the original intent, and then passing that data off into the life cycle, into facility management to use it for operations and maintenance. The same data. Client says we want certain temperature in a room. Architect and engineer designs the room, places equipment and systems in the building. Construction happens, commissioning happens to check if it performs to that specification, and then it's handed back to the owner to be able to manage that facility for the life cycle. So cloud computing is what we use. We basically are in the cloud. In other words, we don't install any software. We have software on our desktop, but our particular system, the ONUMA system, is all in the cloud. You don't install software. You log in and start working just like you do with Expedia. And you'll see a little bit more about that later. So the connection of GIS to BIM, geography, at many different scales, being able to put a latitude and longitude triggers a lot of things, obviously information such as weather, but also sourcing of products in a building. If you want to start looking at leads and sustainability, you need to be able to track everything as you start making decisions in a project. So the eye of BIM,